So this is the UI, the startup screen, and the UI contains 4 different screens, and we just go one by one. I'll explain a little bit what they are doing. So we're starting with the tab manager. Click on tab manager and you are greeted with an empty tab manager screen because we haven't loaded anything. So the first thing you do is to find your car directory, that is usually called my car, in your home directory, which then loads the corresponding configuration file from that directory. To do so, click on that button here, load car directory, and locate your car directory. So it starts, the browser starts in your home directory, and for today I will choose this car directory, which is called my car2. Click on load, and it has now loaded this directory. You could see this in the console. In the background, you would see the familiar command which Donkey prints if it finds the config file here. So this has worked. And from this car directory, we now want to look at tab data. So in order to do so, we need to load a corresponding tab. So I'll press here, load tab, and now I am in that my car2 directory, and the tab I want to look at today is in that folder data1, and it is indeed in the subfolder, so my tab data is here, and I am selecting that tab as an example. So click on that tab, click load, and it will load the corresponding tab data. A quick run through that screen and what we are seeing here. So on the right hand side, this is a navigation panel. It shows you the record that is currently selected, and it shows you a couple of small buttons to move forward and backward through this data. You can see the record count increases and decreases, and the picture, the corresponding image that we have taken, is changing in accordance with that. I could as well run through the tab by using those forward, backward, and stop buttons. I could as well use the arrow keys on the keyboard. I can use right key, left key, or start and stop by hitting the blank key. So this allows me to navigate through that tab data. And what I want to do as well is I want to usually look at the values that I have recorded in the tab. And I can do this by going to the left side of that screen into this record field, and I click on this button, and it shows me in the drop-down menu which data is available in the corresponding records of that tab. So this is normally the minimal amount of data that we record. It's user angle and user throttle, and I will select this data now. And you see, if I let me hit the space button to run through the tab again, you see the values are displayed on the left hand side in numerical form, as well as there's 2 small bars. They show you your steering angle and your throttle value. Okay, so these are the tools to navigate through the tab data. Now what we usually want to do with that data is we do some data cleaning. And the way to do this is to locate the bad data, the bad records. And for this exercise, just assume I want to get rid of the records between 100 and 200, which are not bad in this example, but this is just a demonstration. So if I want to get rid of those records, I would need to locate those records. So I navigate there with a slider or with the arrow keys, doesn't matter, and then I will use that record 100 as the left side of my interval of the data that I want to clean. So I press set left, and then this record 100 gets copied into that interval below there. And now I'll move forward to the right hand side of that interval, which for our example here is going to be record number 200. Same thing, I stop on that record, I press the set right button, and the 200 gets copied into that interval here as well. And now I can go and press the delete button, and it will delete the data between 100 and 200. And then I can move forward and find the next bit of bad data. say in this example, let's say it would be between 500 and 600. So same thing again, set left on 500, move forward to the end of the interval, 600 set right here. I have this interval selected. I press delete and that data gets deleted as well, and so on and so forth. So when I'm done with this and I scroll through the data again, it doesn't seem that the data has been deleted yet. And the reason for that is that the data is just marked as deleted. In order to see the effect of the deletion, we need to reload the tab. So I press this button, reload tab, and it starts again from 0 after the reloading. If I go, take the slider, move forward, and then I see, you probably have seen this, so these records just jump over the interval 100 and 200 because that's the interval that we deleted, as well as this interval further here, 500 to 500 to 600 is missing, as you can see. And so this is the way we get rid of bad data. And if we removed bad data in that way and afterwards decided actually we want to bring the data back, that is no problem, because in Donkey 4X we don't really delete data, we only mark data as being deleted, and the same method that we use to delete the data we can also use to bring the data back. And so let's do the same example as before. So this interval that we chose, 100 to 200, is now missing in my data, but I can very generously set a left and a right point around this interval. I'm somewhere on the left of the deleted data, I'm now somewhere on the right of the deleted data in my interval, and I press not delete, but I press restore. So, and in a similar fashion, I go to this interval that I deleted here. I go to the left-hand side of that interval. I go to the right-hand side of this interval of the deleted data. So this interval covers from left to right all of the deleted data. I press restore, and again, the data will now be restored. And as with the deletion, in order to see the effect, I need to press the reload button. So I can restore a lot of data and press reload only once to speed up the whole process. So let's press reload, and if we scroll through the data, then we see everything is back to where it was in the beginning. So that's the way to manipulate data, to look at data, to delete data, and to restore data back. There is another small thing in that tab manager screen that is worth mentioning, and that is this set filter field, which is a text field here. So you can enter a filter text which will be parsed by the application, which allows you to shrink or to select the data that you want to look at in order to evaluate if you want to use such a filter in your training. And I say a very typical application here could be to select driving records where you drove fast enough. Sometimes if you start the first rounds or if you restart the car after you got off the track, you might be driving relatively cautiously and relatively slowly and afterwards only picking up speed. So maybe you want to train your car only on the data where you've been driving really fast, for example. So let's have a look at what throttle values we have in that tab. Again, I'll just take the slider and just eyeball the numbers here on the left-hand side. And see the numbers are usually between 0.5 and 0.7 even. And let's just put something into that filter to see how it works. Assume I would want to select data only where my throttle value is really high, let's say it's larger than 0.7. So what I can do, I can just type user throttle. So this is the exact string of that field name that you can see in this little display here, and I want this value to be larger than 0.7, say. So if I type into that cell, I need to hit return for that. And then I click set filter. And let's see what happens. You see there's a small status bar below and it says filter result on current record false. That is a good sign because it means the filter was understood by the application and it figured out that the throttle value of 0.6 obviously is not larger than 0.7. But the essential bit here is to make sure that the value that you type in is being understood by the application. It's obviously very easy to make a typing error here, in which case you would see a problem below, and we will show this afterwards. But let's see what happens if I apply that filter. And I have to do the same thing as I did with the deletion and restoration of data. I have to press the reload tab button. If I do that, you can already see the number of records has dramatically gone down on the lower display. You see the counter here. And if I now scroll through those records, they are not continuously any longer, of course, because only the fast records with a high throttle value are now in that tab. All the values are larger than 0.7 as we selected. Okay, so same thing also as with the deletion. I can remove that filter very easily. I need to go in this field again. I need to remove all the text, hit return, and set filter back to this empty value. Again, I have to press the reload tab button and all my data is back. So this filter is actually a test criterion. How does the filter work? If you provide that exact filter that I have typed in that field here into your config file, that it will be picked up by the donkey training command, and you can see visually here which records would be affected by that. I think that's all for now for that tab manager, and we're going to move to the next screen. Okay, so the next screen, that is the trainer screen here, allows you to train a model from the tab data that you prepared in the previous screen. So this is the idea. You do the data first. Once you're happy with your data, you go and train a model on that data. So how do we do this in that screen? In principle, you could go without doing anything else and click this train button and it will train a model straight away, and that's it. But there are small optimizations that you can use here in order to make it a little bit more easy to track what you have been doing, because you see already in this table below, this table is a display of all the models that you trained and that are stored in the corresponding models folder in your car directory. And you see there is already a lot of stuff in there because I've been running this already a couple of times. So in order to remember what you did when you trained a model, it is very helpful, for example, to put a comment for the training into that field. So this comment is displayed in this UI in the very right column, not the very right, but the last, but one column from the right. And you see I put a little bit of text here, not that much, but it's just for me to remember how did I train. Maybe I did some manipulation in the data as before. I selected fast records, or I used some augmentation, or whatever. So I usually put a small comment, such if I see all the different pilots that I trained in this display, I can make some sense out of them. And if I copy them to the car, I have the same, I have access to that same data table here, and I can look on my car. This is the model that I used with augmentation, or this is the model that I used where I used the fast training data, for example. So let's just put a comment here, just say this is a test linear. So we want to put this very short comment here. And so I'm saying test linear because we want to use the linear model for training. And to select the model type, you press into that small field here, and it shows you all the models that are currently available in Donkey. In my version of the UI, it shows a couple more models because I have more models, but it would not apply to you except if you have put more models into this application as well. So the standard model is the linear model, which is pre-selected. So we're going to start with this one. And before we start, we'll look at one more available option, and this is this option that is called the override config option. And what you get to see here, if you click that field, are all the configuration parameters that Donkey Khan knows. This is the union of the two files, of the config file and the myconfig file in the car directory. And you can now go select any of these config variables and override them. And that is useful, let's say. It is not spectacular, but it is useful if you want to change some of the parameters without having to go onto the drive, opening a text editor, changing the value, saving the file again, and doing it from there. So you could very quickly override something that you just want to try. And for this example, a good application here would be, because we want to keep the training short, to just go to find the number of epochs, which is called max epochs, yeah, so which is by default, at least in my version, set to 30, and give it a smaller number. So I set this to 2. And you can also see again on the small status bar here, this setting max epochs to 2 of type int has succeeded. And you can see in that comment here on top of that field, in order for this to succeed, you need to type in the values as in a JSON format, as JSON values, because it's a JSON parser which will parse those values. I mean, there are very few differences between JSON and Python. The most prominent one I have highlighted here. So for strings, you have to use double quotes. You can't use single quotes, otherwise you will not understand it. And you have to use true and false with lowercase instead of with an uppercase T and F like in Python. If you were to put a true with a lowercase, sorry, with an uppercase T, the parser down below would say setting a value of type string. It would interpret a true with an uppercase T as a string, and that's usually not what you want. So be careful with this when you override those values. Apart from this, you can put arrays and strings and everything that you can put into your file, everything that is understood by the JSON parser, into that field to override your settings. Okay, now we've overwritten the settings, we've selected a model, we put in a comment, let's hit this button, and it says training running. That's what it does. And I will quickly jump over to the shell that we use to start the application, and you see the normal Keras screen for the training, where you see the progress, and now you see the training has finished because we selected only 2 epochs, so it's fast. It is now doing the conversion to TF Lite, and if I go back to the application, this button is now back to gray, and the training has succeeded. And if I look into this table below, yeah, the last entry here, this is the model that I just trained right now. So the model will have a unique number, so the number is automatically given by the application, and the name of the pilot is the pilot underscore date underscore number. Yeah, so that's the number 73 that we just created here. It will show you the data that I used for the tab. That is this path here. It will show you the timing when the timestamp of the training, when the training was completed. It will show you your comment, and it will also show you if you used a transfer model to start your training with. So that is something you can do if you have trained a model already and you want to train on a similar course, on similar data. In order to speed up the training, you don't need to start from scratch. You can use a pre-trained model, feed this in and start training from there, which will make your number of epochs significantly lower than if you start from scratch. Okay, so now this model has been trained. I can now go and try out this model, and we can do that in the screen called Pilot Arena. So before going to this, I will stop the recording here and come back in a second. Now that we have trained a model, we can now move over to the Pilot Arena and have a look at the performance of that model on the tab that we used for training, or on any other tab that we've selected in the tab manager. So let's click on Pilot Arena, and the screen should jump over to this view. So here we see the same two images, which are just the same tab image that we see in the tab manager, and we also have the same kind of navigation buttons here going back and forth, and we have the same record fields, although this is just a small selection of those fields. By default it selects user angle, but you can now also add user throttle to that, and so we get to see the data that is normally recorded, that's normally used for training, and that's what we want to evaluate when we have a look at the trained models. So it allows, as you can see, to load two models, one on the left and one on the right hand side. And the main idea for that is to be able to compare two pilots which you've trained, and to see what training parameters or what selection of data or whatever you've done, what augmentation, whatever has made an impact or an effect on the performance of driving with that trained pilot. It is obviously not giving you a full real-world performance impact, because this you would only get through a simulation where you would also see the impact of your pilot giving a different steering or throttle command would move the car into a different position, which would then affect the picture that you would get to see. So that is obviously not a replacement for a simulation, but it would still be able to show you the training performance of that model on the tab data. So let's start with this now. From the trainer screen, I think I recalled that there was a reasonably trained linear model under the number 12. So in order to load this, I will have to firstly choose the model type. And I could now go and just choose linear here, in which case I would need to load the H5 model. But this is the standard Keros model. This is big and it is slow, and it is much more performant if we're using one of the optimized models. And these are, for example, the TF Lite and the Tensor RT models. The Tensor RT models are only generated if you set this in your configuration, and I haven't set this on. It's not set on by default, but the TF Lite models are now always automatically created, and they are much faster definitely on the Raspberry Pi, but they will also be faster on your local computer here. So instead of choosing linear, therefore I choose TF Lite linear for the model, and now I click on choose pilot. It will again open that file browser. Press on load, and now I actually have to load at least one image. You see now these two errors, which are familiar to you if you are using the make movie command in Donkey, where you see the recorded values in the green line represented by the green line, where the length represents the speed or the throttle value rather, and the angle represents the steering angle. And now you can see how these two align with each other from the pilot that I calculated, which is obviously in the blue line on the left hand side. And now let's go to the right side of the panel and choose another pilot as a comparison. So same thing here. We select the type and we now want to use, let's say, the TF Lite memory model, which is under the name TF Lite memory. Okay, and go to choose pilot. I recall it was number 69 if I'm not mistaken. So let's go to this one, select that pilot, hit load, move forward, and so we have the corresponding pilot here. And as you could see, it's maybe not that super obvious, but a typical feature of the memory model is that it is a little bit smoother in driving. Yeah, so the model learns also from the previous steering commands and throttle commands. And as you know, in reality, you will not randomly jump with your steering from left to right or with the throttle values from full throttle to very low throttle and back. But your movements in driving the car are much more smooth. So you will gradually go from driving from left to right, or from accelerating or decelerating. And because of this, you have some kind of a memory effect, which will make it much more likely that your inferred value is going to be closer to the previous values that you had produced as part of the model. And this is a little bit what you can see in this demonstration already. The linear model on the left hand side is more, I don't want to say twitchy, but is making larger changes from one frame to the next, and the blue line on the right hand side you see moves a little bit slower. I would say just optically you can now get a little bit of the impression of what will happen if you drive with a model outside in reality. Okay, so that is the main idea behind this pilot arena. And let's say, what is the comparison to what we have in the Donkey commands? This would be, as a comparison, the make movie command that you are probably familiar with. So you would use your trained model, you would create a movie from that trained model, and you would then look at the corresponding movie, and from this you could basically get the same display and make a judgment about how well does the model perform. And the benefit here is that you can do this with two models simultaneously in parallel, and you can very easily see the impact, and you can sync up the values. I mean, they are synced up automatically. You always have the same frame on the left and on the right hand side. There's another feature that we can look at here as well, and that is the option to overlay your picture with some kinds of disturbance perturbation. And we have these two perturbations that we're also using, making available as augmentations in the training. And one is just a brightness filter. So if I click on brightness here, then I can use the slider and adjust the brightness of the picture. Yeah, and you can see how the values of the model are changing when I change the brightness of the picture. And if you recall, and if I'm not mistaken, from my comment on my training, the left model was a model that was trained with augmentation. And as a result of that, you see if I move that slider to the left, if I increase the brightness of the picture, the model is not really sensitive to that. So even if the picture is super bright, you hardly can't really see, at least I can't definitely see the lanes of the track any longer. The model still does not move the prediction on that blurred and highly distorted data. Whereas the model on the right hand side, which was not trained with augmentation, now clearly is impacted by the absolute light level of the images. And if you can also go into drive mode. If I drive here, you see that the model now under these changed light conditions will not behave as good as the one that has been trained with the augmentation. And you can do the same thing with the brightness, also with the blur. So let me switch this back to normal and use the blur factor here. So the blur just is a Gaussian distortion of those pixel values. And if I crank this up, you see something similar. The effect of blurring seems to be less pronounced on the model performance compared to the brightness. In general, also the model that is not trained on blurred pictures does still behave reasonably well on the blurred images. But also here I think we'd be able to see, yeah, look, if I move the slider a little bit further, you see the model is much more sensitive on the right hand side to this distortion of the picture than it is on the left hand side. So this gives you a good idea how well your augmentation has worked on your data. And I have to say I can also see the effect in reality if I train outside at different light conditions compared to using inferencing and driving the car outside at other light conditions. I can see the augmented models that are trained on the augmented data behave more stable and are less erroneous when suddenly the sun comes out and the track is much, much lighter than it was before. Okay, so that's everything for the train screen, and the next thing we want to look at is the car connector screen. So we are now on the car connector screen, and it says it in very light orange letters on the top. This screen actually really only works if you are on a Linux platform or an OS X on a Mac, because that screen relies solely, completely on an SSH connection that is run through the shell between your computer and the donkey car. And so, because this is not available in Windows, there's no way that this shell, that this screen will work under Windows. So for all the Windows users, they can't really use it. It's not a big issue, because I think this is really the screen that is just an add-on. It doesn't allow you to do anything that you cannot do through the donkey commands and through normal copy commands as well on your computer. But I would nevertheless want to go through this quickly and show what it can do. So you see, while we are talking here, the status here says disconnected on the right hand side, because currently the donkey car that I have is not in my local network. It's even switched off. I'll do the following thing. I'll now plug in the power plug into the car, which now starts up the Raspberry Pi that will try to connect to the Wi-Fi. And once it's connected to the Wi-Fi, it should change the connection status here from not connected, from disconnected to connected, hopefully within the next couple of seconds. So let's wait for this a little bit. And it still seems to be looking for the Wi-Fi. Okay, so you might have seen this has now changed. Definitely the color is now green. It says connected. It means it has found the car on the Wi-Fi and is able to successfully do a SSH connection into the car. And now we can effectively do the data transfer between the car and the computer through that screen. So first thing we have to do is we need to find the car directory on the donkey car, and usually again it's a directory that's called my car in your home directory, but for our exercises here I've chosen a different directory. It's called my car X, and you have to not only type the name of the directory, you also have to hit the return button. Once you do this, you should be able to see all subdirectories of that car directories in that drop-down menu, and it seems to have worked. You will not only see all the sub folders, but you will see the full content, so all the files. The thing that we want to do now is we want to select the tab data for syncing the remote car tab data to your local computer. And in this example, the tab data is just the data folder. That's the standard in Donkey Car. If you haven't set up anything else, it would be in that data folder. So I can select that folder, and I can now pull that data folder into my local directory, which is the one that I selected the tab manager in the very first screen in the very beginning of that session. So also in your local folder, your data folder is the one that would normally be used to hold your tab data, and this is the one that is going to be used to copy that data into. So whatever tab you have chosen in the first screen will be unaffected by that. So the data will go into your data folder of your chosen local directory in your computer. So I will now just click that pull tab data button, and it should now connect through SSH, doing rsync command and copy over the data from the car to the computer. And it is doing something. As you can see, there's now a small blue status bar creeping from the left to the right, and it seems to have more data than what I expected, because it will take a couple of seconds now to complete this data transfer. Afterwards, we would be able to see this data on our local computer. We can quickly check that actually. So if I go into the Finder in the mycar2 directory, in this data directory, you see all of these catalog and manifest files. These are the ones that are currently being copied over from the car to my local computer here. So this seems to be working, and it is still doing something. While I have the option to move the data from the car to the computer, I do have the option also to go the other way around. I haven't mentioned this other button here, create new folder. This create new folder button, if you click this, will do the following thing. It will not sync the data within that remote directory into your local directory, but it will actually copy that data directory under your local directory. So if I would have clicked that folder, the data would have been in data/data, which is normally not what you want, but sometimes if you prefer to have isolated tabs on your car and you have isolated tabs within your data directory, you might want to keep that same structure. You might want a new folder to be created locally under your data folder as well, and in that case you might want to click that button for the transfer. So this process now will finish in a couple of seconds. In the meantime, we can look at the other part of the transfer, and that's pushing the data from your PC onto the car. And the data that you want to push are obviously the trained pilots, that we just created, for example, through the trainer screen, as well as the ones that we created through just the donkey train command or a shell script training 10 pilots in a row. It doesn't matter. All the pilots that you created and that are stored in your models folder can be synced to your car with a single command here as well. So you have this push pilots button that takes care of the transfer, and in order to make the thing a little bit more efficient, you can select the types of pilots that you want to push over. If you do not select anything, it will simply transfer the full directory. But in reality, what you mostly want to do is you want to drive, let's say, on the Raspberry Pi with the TF Lite models, the one that we have also chosen in the pilot arena, because these are significantly faster on your local, on your car than the standard Keras H5 models. Because of the TF Lite quantization, the models are smaller and they are significantly faster in inference. So in order to just sync those models, you just specify the corresponding type that you would want to sync. And I say for me, this is now the TF Lite, and you can press the button push pilots, and we'll now go take all of the TF Lite pilots in your directory and push them over to the car. It will not only do this, but also sync this database file that we saw in the trainer that had all of the training history and all of the data. Just move back. All of this data, all of this big data table, this will be synced to your car as well. So there is a donkey command coming out soon, I think, which allows you to also display this data in the shell. So you don't need to go back and forth between your car and your PC to get access to this table. You can just call donkey pilots or similar, and then you can actually read that data table also on your car, so you can very easily find the corresponding pilot that you want to use to run your car with. Okay, so this has finished now as well, and last but not least, and this is now really a little bit experimental, to be honest, because I haven't been using this much. But last but not least, you will be able also to drive the car and to start the car directly from the application. You can effectively just click drive. Let me click drive here, and we'll actually start the drive command on the car, and would now go, and you could now go actually and drive the car from this. So it has now started the drive loop. I haven't switched on the battery source, so I don't have a remote control or anything else. But the car is now in drive mode. You would now be able to drive it. You can click the stop button, and it will interrupt that process and will actually stall and stop the car, the same as if you hit Control C on your shell on your donkey car. And you can also drive with a pilot, by selecting the corresponding model type here that needs to match the type of the model that you trained, and you can then select the pilot, and this is now showing you a list of all the pilots that we transferred from our local PC here over to the car. You can select any of those, and it will then drive in autopilot mode. Okay, so I think that's it more or less for this introduction, which has taken much longer than I thought it should in the beginning. I think there's one more thing that I should mention, and that is to do with the configuration of the application. So just for demonstration, let me just close it here, and so that is closed, and reopen it again, and let's wait until this comes up again. So again, we are starting with that splash screen here, but now if you click on Tab Manager, you see that the car directory here, as well as the tab directory, they have already been loaded. So the application remembers what you have loaded the last time, and that is quite neat, because then you don't have to go and reload the whole thing again and again if you continue to work on the same data, or you're always using the same directory. That saves you a little bit of time, but from time to time it also can lead to a small error. For example, if you rename the folders locally and then you start the application, you will not find those folders or those data any longer. And I've seen sometimes there are errors actually coming from that setup. So in that case, if you see an error coming up, you would see this here in that shell in the background. There would be some error message here, like something failed to read or to load. So then the best thing to do is to go into your home directory and locate the following file. So if you in your home directory, there's a file that is called donkey.donkeyrc. So that is the configuration file for the donkey UI. If you go and find this file and simply delete that file, this is the file that saves all of this data of the application. And if something goes out of sync, I think the easiest thing is just to go and delete the file, restart the application. All of the data that has been written to this file will be rewritten when you start the application again. Yeah, so this is just something to bear in mind. This thing is not perfect. It's not fail-safe. Some of these errors do come up, and I saw that this is a good, a quick help to get the application back to up and running. Okay, and I think that's it for now. If you have any comments, please feel free to leave comments in the forum, to post issues on GitHub, or to just leave a comment below. And that's it for now. Thank you for listening.